last class we learned the substitution method where we isolate a variable and solve. So which variable would y'all isolate in these two equations to make it the y? So how would I isolate the y? Okay, so before we do that, we got to get y by itself. So we need to make this a y equals equation. So how would we do that? So I got to get rid of this 2x. How do I get rid of it? So I'm going to subtract 2x from both sides. That would get me y equals 14 minus 2x.
Oh. Miss. I forgot. I found my AirPods.
Good. So y equals 14 minus 2x. So since y equals 14 minus 2x, I'm going to substitute 14 minus 2x in for this y value. So it's going to read 5x minus 9 times 14 minus 2x equals 10. Now what? Yeah, distribute. Okay. So 5x, negative 9 times 14 is minus 126. Negative 9 times negative 2x is plus 18x equals 10. Now what? Oh, yes. Look at that vocabulary. Let's combine like terms. So the 5x and the 18x will give me 23x. So 23x minus 126 equals 10. All right, how am I going to solve?
You do the 126 minus plus 10.
All right, so add 126 to both sides.
That's 176. 136.
Thank you. 136.
And you divide 23 with 23. Over.
Perfect. So divide by 23 on both sides. Let me give me some decimal. Yes. Okay. Technically, we're not done, right? We would have to go plug this in to x and solve for y. But because it's decimal and I feel like moving on, we're going to move on. Okay?
Really?
Yes. So we're learning a different method today. The feedback from yesterday, the students like this method better than the substitution method. So if you were tiling your notes, you would label this elimination method. Elimination method. All right, write these two equations down. This lesson today will be shorter than the one for substitution, so hopefully you'll have plenty of time left at the end of class. So write these two equations down and write them on top of each other just like I have here. So x minus 2y equals negative 19 and 5x plus 2y equals 1.
I couldn't find the machine, so I used find my earbuds. It's like they're on the freeway. So what?
Where were they?
I'm my grandma's car.
Well, maybe she was on the freeway.
Huh?
Maybe she was driving. All right, so elimination method. What we're looking for in elimination method is the same variable with the same coefficient with opposite signs. So what we're looking for when we're doing elimination method, we're looking for the same variable with the same coefficient and opposite signs. So positive, negative, or plus and a minus.
Well,
So in these two equations, do you see one that fits this description?
negative 9 is the opposite sign.
So I'm saying between the two equations, they have the same variable with same coefficient, opposite signs.
Yeah.
Which one?
The
First one.
What do you mean the first one?
like the 2 minus.
No, the second one, because same variable is.
So I'm asking about which variable, the x's or the y's?
Oh, the
The
y.
y's. So the y's,
Oh,
there's both of the equations have y's, same variable, with the same coefficient. They both have 2 and opposite signs, a plus and a negative. Because they have this, what I can do is eliminate. So I'm going to put a line underneath both of these equations. And I'm going to combine them. So x's with x's, y's with y's, and the constant with the constant. So what is 1x plus 5x?
6.
6x. What about minus 2y plus 2y? What would happen to these?
Negative plus a positive equals a negative, which is negative 4.
So if I have negative 2y and positive 2y, what happens to them?
Oh,
They cancel out. They're gone, right? They eliminate. They eliminate. So bye-bye, y's equals, what is negative 19 plus 1?
I got you.
Negative 18. So now there's no y. This just says 6x equals negative 18. So how would I solve for x? Divide by 6 on both sides. That gives me x equals negative 3. There's my x value. Yeah. But we're not done, right? We got to go find our y value. So it doesn't matter. So I'll say this for this first one. We know that we have to plug x back in to find y. It doesn't matter which equation you use. I'm going to use the top one because they're smaller numbers, so less work for me to do. So I'm going to use the top equation to solve for my y value. So substitute x equals negative 3, so I'm going to substitute negative 3 in for x. So negative 3 minus 2y equals negative 19. I don't know why I put the parentheses. Let me take those off. So solving for y, I would add 3 to both sides. That'll give me negative 2y equals negative 16. Then divide both sides by negative 2. Y equals 8. So my solution would be negative 3, 8. And there's my answer. Okay, questions? Confusion? Understanding? So what we did, we combined our equations and we eliminated the y because they had the same coefficient and opposite signs. So those eliminated, which left us just with x and the constant, and we solved for x and went back in and found our y value. So some people prefer this method. Honestly, it just depends. If they're both in standard form, then yeah, I prefer this method. But if one was like in slope-intercept form and one was in standard form, I prefer the substitution method. When you get to algebra 2, it gets a little bit more complicated because then you have x, y, and z and 3 equations and stuff like that. Much more fun. All right. So this is me just explaining this. So your turn. You try. So write these down and let's see what you get. And then I'll call on somebody. So 2x plus y equals 3. X minus y equals -6. All right, anyone want to go for it? All right, babe, go.
So I wrote it out and then I canceled out the
Mm-hmm.
and then X plus
Awesome.
and then it's 6. Oh wait, it's I thought it was 3. Why was it 3? Oh my god. Okay, never mind.
Okay. So 2x plus 1x gives us 3x. 3 plus -6 gives us, uh-huh. So I'm going to divide both sides by 3. Did y'all get x equals -1? Good. So then you got to plug that back in to find your y. It's okay. We all make mistakes. Trust me, literally yesterday, I kept getting something wrong and everyone else was getting a different answer. I was like, whatever. And so they were getting the right answer and I kept getting the wrong answer. So, all right, so I'm going to plug it in back to the first equation. It doesn't matter which one you do again. So 2 times 1 is -2. Add 2 to both sides. Did y'all get y equals 5?
Yes.
Good job. So the solution is -1, 5. Yay! So Leo, I'm coming to you next time. You got this. All right, so that's my x value and my y value. All right, you ready to get spicier?
Wait.
Okay, I'm waiting. Did you not get something?
I did. I did. Wait, where's the pencil sharpener?
Back there, but I think it's broken, babe. Sorry. You want me to wait, Noah?
Okay, I got it.
Okay. All right. So write these. No, not this one. Write these two down. 3x plus 3y equals 15. -2x plus 3y equals -5. 3x plus 3y equals 15. Negative 2x plus 3y equals negative 5. All right, so we're looking for same variable, same coefficient, opposite signs. Do we see that? No. Do we see at least the same coefficient? 3y and 3y, right? Okay. So it's not hopeless. We can do something about this. We know there's the same coefficient. We just need one of them to have an opposite sign. What could I do to make this an opposite sign? What could I do to make that plus 3y a minus 3y? No, I can't just erase it and put minus 3y. That would change the whole equation. What could I do? You think you know, Sophia? What could I do? What could I multiply the whole, let's say this first equation. What could I multiply this whole thing with to make this just become minus 3y? Not changing any of the numbers. Just want to change the signs. Yes, I can multiply this whole thing by -1, which would make my sign change. Now, a lot of people asked yesterday, what do you mean? How can I just multiply the whole thing by -1? The reason why I can multiply the whole thing by -1 is if I multiply the whole thing, I'm keeping the equation balanced. Because what I do to one thing, I'm doing it to the whole thing. I couldn't just multiply this by -1 because that would change the whole equation. But if I multiply the whole thing by -1, I'm keeping the same equation because I'm doing it to everything in the equation. So -1, we'll change that to -3x minus 3y equals -15. And if you actually graph this, if you actually graph these two equations on Desmos, they would be the same equation.
So like you didn't get the -1.
I just multiplied it by -1. So it's not changing it, and I could prove it if I change both of these into y equals mx plus v form. It'll be the same equation. All right, so the first equation is now this. Let me put the second equation underneath it. Now I should be able to do it. Use the elimination method. Anyone want to talk us through it while everyone's doing it?
Wait, let us do it first.
Okay, you want to do it first? Okay. I know.
But okay. It's -4.
I don't know what the answer is. Are you ready to talk me through it?
Yeah, really.
Oh my god.
But yeah, I got it.
Okay, go.
So -3x minus 2x equals -5.
Mm-hmm.
And then you cross out the 3y and the 3y.
Mm-hmm.
And then you do -15 plus -5, which is -20.
Mm-hmm.
And then you divide by 5, -5.
All right, so very close. You'll get +4. Yes.
Positive. I forgot a negative.
Negative divided by negative. All right, x equals positive 4. Is that what y'all got?
I did the freaking same thing again.
The same thing? It's okay. Well, at least you know what it is. Now just don't do it again.
I literally just keep switching the numbers. Like I'm like, okay, I'm gonna write that down, and then I write.
All right, so going back, plug it into any of the equations, find out what the y is. I'll do it to the second equation. Okay, don't say it. Is that what you got? Okay. I didn't say it.
You wrote it.
Is that what you got, Leah? Good. Sophia, is that what you got?
Miss, you made me delete it. I don't have the notes anymore.
Noah, you were so funny.
I'm serious.
What?
I don't have it anymore.
I'm sorry.
It's your fault.
Okay.
Accidentally.
What, babe?
How do you spell accidentally?
How do you spell accidentally? Ask Siri.
Yeah.
A-C-C.
I don't trust her.
A-C-C.
Tell me slow down now. A-C-I.
ACCIDENTLY.
I-D. There you go. Appreciate it, miss.
What?
I said there it goes. Appreciate it.
You're welcome. All right. Can I move the slide? All right. So this is me just explaining it. All right. Okay. All right. Last one. Last example we're gonna do. Are you making fun of me? Don't make fun of me. That's not nice. Mm.
That's really.
Little late there, boo.
I'm gonna say that.
This is like the same thing that we did.
Yes. Okay. So what we want, this is still elimination method. And what we want still is the same coefficient.
Why is that stuff popping? Like that?
I don't know.
The dot.
Same coefficient with opposite signs. That is still our goal. Same coefficient with opposite signs. Do we have any of that? No. We don't have same coefficient. We don't have, well, we do have opposite signs, right? We have a positive 2x and a negative 3x, a positive 5y and a negative 4y. So we have the opposite signs part, but we don't have the same coefficient part. What are we going to do?
We're going to do math. You multiply by 1.
Would that make them have same coefficients?
You add everything over.
Would that make it, well,
You're adding every number, so you're taking the changing the number.
okay.
Okay.
Here's my,
We got along.
all right, here's my question.
I'm saying okay.
Can I make them have the same coefficient? Yes. The answer is yes. So I'm going to pay attention to the x this time. 2 and 3. What is the least common multiple for 2 and 3?
What? What does that mean?
2, 4, 6, 3, 6, 9. What's the least common multiple? Hold on. 6, thank you. 6 is the least common multiple. So what would I have to multiply this first one by to make this a 6?
1.5. What's 6?
Oh my gosh, stop. Literally, I'm trying to record this. What would I multiply this by to make the 2 become a 6? What? 2 times what equals 6?
4.
No.
8. I was thinking 4 plus 2. Basic ones.
Okay,
I was
3.
thinking of 4 plus
Okay, thank you. What would I multiply the bottom equation by to make this 6? 2, thank you. Oh, well, okay. So the top equation, I'm gonna multiply it by 3 so that the coefficient in front of x becomes 6. I'll multiply this by 2 so the coefficient in front of x becomes negative 6. So let me go ahead and distribute my 3, and I'm gonna distribute the 2. That was slightly scary.
Miss, I was thinking
I understand. So the first equation will become 6x plus 15y equals, what's 26 times 3? 78. Because 3 times 2x is 6x, 3 times 5y is 15y, 3 times 26 is 78. And then the bottom equation, 2 times negative 3x is negative 6x. 2 times negative 4y is negative 8y. Yes. And 2 times negative 25 is negative 50. So now,
these are some big numbers.
so now it looks just like we've been doing.
No.
So 6x
Cancels out.
and negative 6x cancels out.
15y minus negative 8. It's just negative.
Oh,
It's
I
just
know.
3.
Hold on. 15y combined with negative 8y would give me,
7.
No, Miss, you subtract that because there's a plus right there.
yes. So
I
be
said that.
it'd be 7y. You kept saying 3.
No.
Mm.
I'm
So you
saying
can either say like this, 78 plus negative 50 or 78 minus 50. It's the same thing.
What's the difference?
It's the same thing. So equal 28. So now I'm gonna divide both sides by 7.
It's 4.
Y equals 4. Look, or we got back to the number 4. So y equals 4.
Go 4.
Remember when Noah was saying 4? So y equals 4. So I got to plug that back into one of the equations to find my x value.
I always forget 2, 4. I forgot how to put the other. Oh, I was putting in the wrong.
It doesn't. If you can eat. Bless you. You can put it into either of the original equations, or you can put it into either of the modified equations. It'll still give you the same answer. It doesn't matter what you plug y back into. You can plug it into the original equations or into the modified equations. It'll give you the same answer.
Don't say the answer.
Okay, I won't say the answer.
It's fine. You get 3, 4.
Yes, I got 3, 4.
Let's go.
Which one did you plug it back into, babe? Okay, the positive 6x one. So 6x plus 15 times 4 equals 78, like that. So then you got 6x plus, what's 15 times 4? 60.
Yeah.
60 equals 78. Subtract 60 from both sides.
Oh my god.
Simple mistakes.
Yeah, I'm like, what is wrong with you today?
It's okay.
It's Friday.
It's okay. It's Friday, the day before the break.
I always do that.
Okay. Mayada, are you good? Okay. So that's it. What we're going to do is, I mean, you can thank me later, but there's only 5 questions for today's assignment. Noah, are you really about to roll your eyes at me?
I don't